So, good morning class. Today we will discuss about the mechanism or the entire process involved in the formation of covalent bonding. So, we have discussed about main features of covalent bonding. We have seen how a covalent bonding is formed, but now we will see what is the actual mechanism behind the formation of covalent bonding. So, basically when we are discussing about the formation of covalent bonding, so basically we have to discuss two theories. So, we are going to discuss formation of covalent bonding and we are going to discuss the exact mechanism for that. So, for that purpose we have to discuss two theories. The first one is valence bond theory and the second one is molecular orbital theory. So, we have to discuss 2 points, two theories. First one is valence bond theory, also called Pauling-Slater theory, and the second one is molecular orbital theory. Now, so we have to discuss 2 points. First one is VBT and the second one is MOT. VBT is valence bond theory and the second one is molecular orbital theory, and the second one is molecular orbital theory. So, we have to discuss 2 points, valence bond theory and molecular orbital theory. So, let me give an overview of both of this. Molecular orbital theory and valence bond theory are the two theories given for the exact mechanism involved in the formation of covalent bonding. But valence bond theory has been rejected because it had some limitations that we are going to discuss in the next sections. But till now molecular orbital theory is standing because it has none of the limitation as well as it fulfills all the limitations which was present in valence bond theory. So, valence bond theory has been rejected and still we follow molecular orbital theory. So, now let us discuss briefly the two theories. So, we are going to discuss the first theory, that is VBT, and it is called valence bond theory. It is called valence bond theory. So, first of all let us see some of the postulates or some of the characteristic features of valence bond theory. There are some of the main theories or main points which can be summarized in valence bond theory. So, the first one is, it says that whenever atomic orbitals having unpaired electrons come close to each other, then they overlap and leads to the formation of covalent bond. So, the first point says whenever two atomic orbitals having unpaired electron in both the atomic orbitals, when they come close to each other, then they overlap and leads to the formation of covalent bonding or covalent bond. The second point says that for the formation of covalent bond, the electrons should be unpaired and as well as electrons should be in opposite spin. The opposite spin means that one should be in clockwise and the other should be in anti-clockwise spin. So, the spins of electrons should be always opposite. If one electron is having clockwise revolution, then the other electron should have anti-clockwise revolution. Third point says, if the electrons have same spin, then repulsion takes place and no bond is formed. So, the third point says, if the two atoms, if the two atomic orbitals having unpaired electron, they have unpaired electron, but the spins are not same, but the spins are same, but that means if both of them are in clockwise or both are in anti-clockwise direction, then in that case the both electrons will repel each other, and in that case no bond will be formed. Next point says, the next point says that the degree of overlapping is directly proportional to the strength of bond. More will be the overlapping, so more stronger would be the bond formed. So we can say that strength of covalent bond is directly proportional to the extent of overlapping. The more will be the overlapping, the stronger would be the covalent bond formed. So the next point says the strength of bond will be directly proportional to extent of overlapping. The more will be the overlapping, the stronger will be the bond which is formed. Now let us see some more features of valence bond theory. Next point says, if an orbital possesses more than one unpaired electron, then multiple bonds may be formed. So it says that just now we discussed about unpaired electron. This says that if an orbital is having more than one unpaired electron, then in that case more than one bond may be formed, that is either double bond will be formed or triple bond will be formed, but it will happen only when that the atomic orbital has more than one unpaired electron. It will only happen that time when the atomic orbital has more than one unpaired electron. Next point, the covalent bond lies in the direction of maximum overlapping. It lies in the direction of maximum overlapping, and so we say that covalent bonds are directional in nature. So we say the covalent bonds are directional in nature. So the next point says that the covalent bond will assume its direction, and on that direction or on that plane wherever they will have maximum overlapping. So that is why we say covalent bonds are directional in nature. And the next point says that after the formation of covalent bonding, the atomic orbitals retain their identity. They do not lose their identity, they retain their identity. So these are some of the main features of valence bond theory. Valence bond theory is also known as Pauling-Slater theory because it was further developed by Linus Pauling and J.C. Slater. So valence bond theory is also known as Pauling-Slater theory because it was developed by Linus Pauling and J.C. Slater. So these are some of the major features of valence bond theory or Pauling-Slater theory. It is also called Pauling-Slater theory. So let us see once again the important features. First of all, it says, valence bond theory says, whenever atomic orbitals having unpaired electron approach each other, then they overlap and leads to the formation of covalent bonding or covalent bond. The second point says that the covalent bond will be formed only when the atomic orbitals have unpaired electron and the electrons should have opposite spin. Opposite spin means that the first electron, if the first electron is having clockwise spin, then the other electron should have anti-clockwise, and vice versa the case may be. Next says, if the electrons have same spin, then in that case repulsion will take place and no bond will be formed in that case. Next point, the strength of our covalent bond formed, the strength of covalent bond is directly proportional to the extent of overlapping. More will be the overlapping, greater will be the strength, lesser will be the overlapping, lesser will be the bond strength, means the bond will be weaker. So, this is the most important point. Next point, it says that if an orbital has more than one unpaired electron, then in that case multiple bonds may be formed. The multiple bonds may be either double bond or triple bond. Covalent bond always lies in the direction of maximum overlapping. That is why we say covalent bonds are directional in nature, because they will lie in that direction wherever the overlapping will be maximum, and that is why we say that covalent bonds are directional in nature. And the last point says that the atomic orbitals retain their identity even after the formation of covalent bonding. So, this is this last point which says that the covalent bond retain their identity, the atomic orbitals retain their identity even after the formation of covalent bonding. This is the main differentiating feature of molecular orbital theory and valence bond theory. Later when we will discuss about molecular orbital theory, therein we will see that after the formation of covalent bond, the atomic orbitals lose their identity, but here they are retaining their identity. So, this was mainly about valence bond theory. Now, let us discuss about the case of overlapping. We will discuss about overlapping and we will see how many types of overlapping can be there and how it takes place. We will see the various cases of overlapping. So, mainly when we are discussing about overlapping, so we have to discuss about three types of overlapping. First one is SS overlapping, that is overlapping between two s orbitals. Then we have to discuss about SP overlapping, overlapping between one s orbital and one p orbital. And the third case is of PP overlapping, the overlapping between two p orbitals. And further, when we are discussing about PP overlapping, we have to discuss further PP overlapping of further two types, that is axial overlapping, they will be on a particular axis, and the next second one is sidewise overlapping. So, these are the various types of overlapping that we have to see in case of formation of ionic covalent bonding according to valence bond theory. So, these first of all, when we are discussing about overlapping, we have to discuss three types of overlapping: SS overlapping, SP overlapping and PP overlapping. When we are discussing about PP overlapping, we have to discuss it is of further two types, that is axial overlapping when the two p orbitals lie along the same axis, and sidewise overlapping when the two p orbitals they remain side by side opposite to each other. So, now we will discuss these types of overlapping in detail. So, let us see some of the types of overlapping. So, first we are going to see the case of SS overlapping. So, we know that s orbital is spherical in shape. This is our first s orbital and this is our second s orbital, and since two s orbitals are being overlapped, so it is a case of SS overlapping. It is a case of SS overlapping. The next is the category of SP overlapping. So again we know that our s orbital is spherical in shape, but our p orbital is dumbbell in shape. So this is our s orbital and this is our p orbital, and since it is a overlapping taking place between s orbital and p orbital, so it is called sp overlapping. So it is the case of ss overlapping, when the overlapping is taking place between two s orbitals. This is our first s orbital and this is our second s orbital, and here this is the case of sp overlapping, because it is the overlapping taking place between one s orbital and one p orbital. This is our spherical s orbital and this is our p orbital, which is dumbbell in shape. So we have discussed about first two types of overlapping. Now we have to discuss the case of sp overlapping. Now we have to discuss the case of sp overlapping. So in case of sp overlapping, first category is of axial overlapping. So when we are discussing about axial overlapping taking place between two p orbitals, so this is our first p orbital and this is our second p orbital. This is our first p orbital and this is our second p orbital, and since the overlapping is taking place between two p orbital and just because they are on the same axis, so it is called axial pp overlapping. And as a result of axial pp overlapping, always sigma bonds are formed. Sigma bonds are formed. But when the case is of side-wise overlapping taking place between two s orbitals, so we have two p orbitals. This is our first p orbital and side-wise of this will be the next p orbital. So since this is our first p orbital and this is our second p orbital, and because the two p orbitals are overlapping side-wise to each other, so it is called side-wise pp overlapping. And as a result of side-wise pp overlapping, always pi bonds are formed. Pi bonds are formed as a result of pi overlapping or side-wise overlapping. So these are the types of pp overlapping. So these are the two types of pp overlapping. First one is axial overlapping and the second one is side-wise overlapping. When we are discussing about axial overlapping, we have two p orbitals which are on the same axis, exist to each other, and this type of overlapping between two p orbitals is called axial pp overlapping. And as a result of axial pp overlapping, always sigma bonds are formed. But when the two p orbitals lie side-wise to each other or laterally each other, so in that case this type of overlapping between two p orbitals is called side-wise pp overlapping. In the last term we discussed about valence bond theory. We discussed about the postulates of valence bond theory and saw the cases of overlapping, ss overlapping, SP overlapping and PP overlapping, and further PP overlapping was of further two types, that is axial overlapping and sidewise overlapping. And in last turn we studied that if there is axial overlapping, then always a sigma covalent bond will be formed, and if there is sidewise overlapping, then there will be formation of pi bonding, pi covalent bonding will be formed. Now, we know that if there are two atoms having a single covalent bond, if there is a single covalent bond between two atoms, then this covalent bond will always be sigma bonded or sigma bond. If the two atoms have a double bond, a double covalent bond in between, then one is sigma and the other one is pi. And if both the atoms have a triple bond in between, then in triple bond the first and the last one are pi and the middle one is always sigma. So, this is the major what we studied about overlapping. So, this is the application of overlapping. Sigma bond will be formed when there will be axial overlapping between two p orbitals, and pi bond will be formed, pi covalent bond will be formed when there will be sidewise overlapping between two p orbitals. So, if there is a single covalent bond between two atoms, between two non-metals, so it will always be pi sigma bond. But if there is a double covalent bond between two atoms, then the first one will be sigma and the other one will be pi. And if there is a triple covalent bond between two atoms, then the first and the last will be pi and the middle one will be sigma. So, this was the application of overlapping. Now, we will discuss about the limitations of valence bond theory, that is limitations of VBT. We will discuss why VBT was rejected and what are the limitations of valence bond theory. So, the valence bond theory has mainly two limitations. The first limitation is it does not explain the formation of coordinate bond, that is it does not involve lone pair of electrons. There is no involvement of lone pair of electrons. And the second one is it does not explain the paramagnetic nature of oxygen molecule. So, these are the two limitations, mainly the two main limitations of VBT or valence bond theory. The first is it does not explain the formation of coordinate bond, that is it does not involve any postulate regarding lone pair of electrons, and we know that in case of coordinate bond there is always involvement of lone pair of electrons. And the second limitation is it does not explain the paramagnetic nature of oxygen molecule. Now, what is this paramagnetic nature? Basically, when we are discussing about magnetic properties, there are two main properties, that is paramagnetic property and diamagnetic property. There are two properties. Paramagnetic property is defined as when an orbital has unpaired electron. This unpaired electron can be one or more than one, and when it is diamagnetic, it will have always paired electrons. Electrons will always be paired. So, basically we have to discuss about two main magnetic properties. There are 5 main magnetic properties, but just now we will discuss about only 2 magnetic properties. First one is paramagnetic property and the second one is diamagnetic property. Paramagnetic property is defined when the atom possesses even a single unpaired electron. If there is unpaired electron in any of the orbitals, then it is called paramagnetic in nature. But if all the electrons are paired, if there is no unpaired electron, then it is called diamagnetic in nature. So, the second limitation of VBT is it does not explain the paramagnetic nature of oxygen molecule. So, these are the two limitations. First is it does not explain the mechanism involved in coordinate bond formation, and the second one, it does not explain the paramagnetic nature of oxygen molecule. So,